In the heart of the Arabian desert, engineers are attempting what ancient civilizations never could, creating an artificial river by moving an ocean across a mountain range. And the $500 billion physics puzzle they're solving could reshape the future of arid nations worldwide. This is the story of a project so vast, so audacious, it borders on science fiction. A project not of simple pipelines, but of a fundamental reordering of nature. It is called the Red Sea to Dead Sea Conduit, but that clinical name hides its true scale. This is a proposed mega-engineering feat to carve a tunnel through the very bones of the earth, the mountains of the Arabian Peninsula, and siphon seawater over 100 kilometers inland. The goal? To generate power, to create fresh water from the sea, and to stabilize a dying landmark. But the deeper you look, the more this modern marvel begins to echo with the ghosts of ancient ambition and confront a wall of scientific paradoxes that could make it the most dangerous gamble in engineering history. Act 1. The Mirage and the Mountain. For millennia, the deserts of the Arabian Peninsula have been defined by one brutal, simple absence: water. Ancient Nabateans carved ingenious cisterns into rose-red rock. Empires rose and fell on the location of hidden wells. The dream of bringing the sea to the sand is older than recorded history. It is a siren song of absolute abundance. Today, Saudi Arabia, a nation built on a different kind of buried wealth, faces a looming crisis. Its aquifers are draining, its population is growing, and its ambitions demand a solution as monumental as its skylines. The vision was born from a terrifyingly simple map. To the west, the Red Sea, a vast reservoir of saltwater. To the east, the Dead Sea, the lowest point on Earth, evaporating so fast it is literally sinking, creating vast sinkholes that swallow the land. The idea? Connect them. Let gravity do the work. Drop seawater from the Red Sea down over 400 meters to the Dead Sea, spinning hydroelectric turbines along the way. Use that power to run massive desalination plants, produce fresh water, save a sea. It is an elegant loop of cause and effect, a perfect circle. But between the vision and the reality stands a formidable barrier, the Al Sarawat Mountains. This is not a simple hill to cross. This is a jagged, seismic, geological fortress. To move an ocean, you must first conquer a mountain range. And that is where the first cracks in this perfect plan begin to appear. The initial concept seems sound. Water flows downhill. The difference in elevation between the two seas is a colossal battery waiting to be tapped. Engineers began drafting. The numbers, however, quickly spiraled into the realm of the surreal. The pipeline or tunnel would need to be massive, wide enough to carry a significant fraction of an entire sea. It would need to traverse over 180 kilometers of some of the most tectonically unstable terrain on the planet. The construction would be a nightmare of tunneling through granite and fault lines, a project dwarfing the Channel Tunnel. The estimated price tag ballooned to $500 billion, but the cost is just the entry fee. The real dangers are written in the language of physics and chemistry. This is where the project transforms from a difficult build into a potentially apocalyptic experiment. First, the brine. The desalination process doesn't create just fresh water. It creates a hypersulpy, chemical-laden waste product called brine. The plan? Dump it into the Dead Sea. But the Dead Sea is already a saturated chemical soup. Scientists began modeling the outcome. They discovered a terrifying possibility: stratification. The less dense Red Sea water might not mix with the dense Dead Sea brine. It could form a separate layer, a lid on the ancient waters. This lid would trap organic matter below, which would decompose without oxygen, releasing massive clouds of toxic hydrogen sulfide gas, a poisonous, flammable, and foul-smelling menace. One earthquake, one landslide, could release a deadly bubble from the sea, suffocating everything downwind. Then there's the gypsum. Mixing the different mineral compositions of the two seas could trigger a spontaneous, uncontrollable crystallization of gypsum. The Dead Sea could quite literally turn into a churning, white plaster-like slurry. It would become a bizarre, solidifying monument to human interference. And finally, the seismic trigger. Pumping immense pressure of water through eternal, deep under active fault lines is like holding a jackhammer to the Earth's crust. Could the project itself induce the very earthquakes it must survive? Engineers are now trapped in a paradox of their own making. To save a sea, they might have to kill it first. To create freshwater, they might unleash a toxic catastrophe. The perfect circle has become a Mobius strip of unintended consequences. Act 3. The unbuildable solution. So where does this leave the $500 billion pipeline? Is it a blueprint for the future or a tomb for a dead sea? The confrontation with these scientific horrors has not killed the project. It has forced an evolution. The current vision is no longer a single, desperate gambit. It is a phased, cautious experiment. A much smaller pilot plant is now the focus, designed not to fill the Dead Sea, but to test the chemistry of mixing on a manageable scale, to see if the stratification occurs, to witness if the gypsum forms. It is a $10 billion science experiment with the entire region's ecosystem as its laboratory. The dream of a river across the desert persists, because the problem it solves is not going away. Arid nations from Africa to Australia watch closely. If Saudi Arabia can solve this physics puzzle, if it can master the chaotic chemistry of two seas, it will have unlocked a template, a terrifying, expensive, but potentially world-altering template. The confrontation, therefore, is no longer just with mountains and money. It is with a deeper, more philosophical conflict, our desire to engineer our way out of planetary limits, pitted against the chaotic, unpredictable systems of the Earth itself. The project asks a fundamental question of our age. Is there a problem so complex, so intertwined with natural law, that even unlimited wealth and will cannot solve it? Or is this simply the necessary, painful, and dangerous price of survival in an increasingly thirsty world? The secret pipeline is no longer a secret. Its blueprints are public, its dangers are documented, its price is known. Its future, however, remains suspended, like a droplet of red seawater held over the abyss of the Dead Sea, waiting to see if its fall will bring life or trigger a chain reaction we can no longer control. The desert's ancient mirage of water has been replaced by a modern one, the mirage of total control. And somewhere in the space between those two visions, between the ancient dream and the terrifyingly possible future, the fate of an inland sea and a model for the world hangs in the balance.